Gravitational quantum coherence and living matter. In the following, I will discuss topological geometrodynamics-based view. It is good to start by comparing the Penrose-Hameroff view, orch-or, with what might be called a standard view, which forms the basis of tgd approach. The standard view might be as follows. Consider n-particle quantum state with localized particles. Localization is essential. In this kind of state, the gravitational interaction energies between particles are well defined. And one can talk about gravitational self-interaction energy. It does not depend on center of mass coordinates of the system. One can shift the system and nothing changes. This is true also for wave functions. The self-interaction energy does not depend on wave function in center of mass degrees of freedom. It depends, of course, on wave function in relative degrees of freedom. So, this kind of n-particle configuration defines a point of superspace of Wheeler, regarded as a space of free geometry. Wheeler assumes that this determines everything. And n-particle wave function for matter, it defines a wave function in superspace of these free geometries. One can have a kind of generalization or equivalence principles. Matter, quantum state of matter, determines quantum state of gravitational interactions. This is a starting point of tgd approach. Consider now orch-or. In Penrose-Hameroff theory, one considers two states. First, wave function for a system, kind of peaked distribution, and then its superposition with its shift in center of mass degrees of freedom. This is essential. And we already noticed that in this first approach, this gravitational self-interaction energy is not affected. One can have all kinds of wave functions. Also these kind of superpositions of two peaks. Nothing changes. Penrose assumes that wave function is not fundamental, but determined by gravitational field. And he proposes that this probability density multiplied by mass for single particle system can be treated as an effective mass distribution. To it, one can assign an effective gravitational self-interaction energy. And one can calculate gravitational self-interaction energy for all kinds of distributions. And it depends on this wave function. And one does it for this single peak and two peaks, these wave functions. And the difference is non-vanishing. And it is assumed to give an estimate for the time scale of gravitational wave function collapse. Uncertainty principle is used here as a dimensional estimate. There are two views on what tgd is. Physics as geometry, entire quantum physics as geometry, and entire quantum physics as number theory. In the following, I very briefly describe both views. Consider first the view of physics as geometry. The starting point of tgd is energy problem of general relativity. One has this kind of situation. One starts from special relativity, flat space-time, and goes to general relativity. The space-time becomes curved. The symmetries, Poincaré symmetry of Minkowski space is lost. By Noether's theorem also the conservation laws of momentum, energy, and so on are lost. And this is a problem. I saw this as a very serious problem. And the proposed solution is that one replaces space-time as a four-dimensional surface, inserting a higher dimensional space, which is Minkowski space, with points replaced by some very small internal space. And the standard model symmetries dictate what the choice is. It is CP2, complex projective space of two complex dimensions. And one obtains standard model symmetries and new view of gravitation. There is also another approach. TGD can be regarded as a generalization of string model. One starts from point-like particles. In string model, one would replace them by strings. Now one replaces them with three-dimensional surfaces. And its orbit would be a four-dimensional space-time surface. This would be the interpretation. At the microscopic level, space-time would consist of this kind of orbits of three particles. And dynamics emerges as dynamics of three-dimensional surfaces in this embedding space, eight-dimensional embedding space. Symmetries are dictated by this embedding space. And here one has a visualization of CP2, complex projective space. This replacement of space-time as a surface in this embedding space has rather radical implications. First of all, the notion of space-time generalizes. One can visualize this by glass plate analogy. One has very thin glass plate. Minkowski space defines this plane of glass plate, and CP2 defines its thickness. It is extremely thin, 10 to 4 Planck lengths or so. And space-time surfaces are inside this glass plate. They can have all kinds of topologies, but at long length scales they approach to Einsteinian spacetimes with four-dimensional Minkowski space projection. One has this kind of many-seat instruction, very many seats locally looking like Minkowski space. And this is the first implication, and obviously it has this topology differs very radically from the standard view. And then topological field quantization and the notion of field body are further implications. Also the classical fields assigned to physical system, they correspond to space-time sheets with finite size. This is topological field quantization. One can assign to system field identity, kind of field body, magnetic body in particle, magnetic body, electric body. And this kind of network formed by magnetic flux tubes connecting nodes as electric bodies would be central in quantum biology. Here I have visualized this many-seated space-time. There are seats of various sizes, and they are connected by wormhole contacts illustrated in the first picture, and they are extremely near to each other. And what is important is that they have boundaries. They have either they have boundaries or the Minkowski space projections have boundaries. And we indeed see everywhere boundaries of boundaries of physical objects, so that we would see this wild topology of space-time everywhere. We can't see these different space-time sheets, but we can see their boundaries. And then this field body, here it is illustrated, this field body, it is these two objects look very similar, and it might be true. There will be kind of holographic correspondence between this physical system and this magnetic body, field body. Quantum tgd as a geometrization of quantum theory. The basic vision is that one geometrizes not only gravitation, not only classical gauge fields, but entire quantum theory. Quantum tgd is analogous to wave mechanics. The four-dimensional general coordinate invariance, it must be realized, but without path integral, because this would give rise to horrible divergences. This requires holography, and space-time surfaces would be analogous to Bohr orbits. These Bohr orbits need not be unique. How to realize this Bohr orbit property or holography? The idea is that one has two-dimensional holomorphy of string models, which is generalized to four-dimensional case. Extremals would be universal, since field equations would be purely algebraic. There would be no dependence on action except at singularities, if action is general coordinate invariant, and if it is expressible in terms of the induced geometry. The spacetime surfaces would be four-dimensional analogs of soap films with frames, at which the minimal surface property would fail, as also universality. This minimal surface property means that one has analogy with massless field equations, and the spacetime surface itself is analogous to geodesic line, which is also minimal surface. So that the analog of particle-wave duality would be realized. Okay, quantum tgd would be wave mechanics for particles as three-dimensional surfaces, but replaced with Bohr orbits. The superspace of Wheeler would be replaced with world of classical worlds, as I call it. It would consist of space-time surfaces obeying holography as analogs of Bohr orbits. Zero-energy ontology is implied by this picture. The wave functions or the generalizations as spinor fields of world of classical worlds, they would be quantum superpositions of Bohr orbits inside a quantization volume, which would be causal diamond, intersection of future and past directed light cones. It would serve as a quantization volume. And ZAO-based quantum measurement theory, it solves the basic paradox of quantum measurement theory. Just because the basic objects are four-dimensional rather than three-dimensional. And one important implication is that the arrow of time changes in ordinary state function reductions. Second kind of state function reduction is analogous to the weak measurement of quantum optics. In this state function reduction, arrow of time is not changed. The infinite dimension of world of classical worlds gives hopes of a unique coherent geometry and spinor structure. Fried demonstrated this for loop spaces and found that maximal isometries are needed. And there are excellent reasons to expect this also now. Physics could be unique from its existence. Physics as number theory provides a second approach to tgd. It involves several parts: classical number fields, reals, complex numbers, quaternions, octonions are all parts of this approach. Quantum tgd can be seen as analog of wave mechanics. Point-like particle is replaced with a three-dimensional surface, And we know that momentum-position duality is central for wave mechanics. This must be generalized. Particles become free surfaces, so that particle orbits become four-dimensional surfaces. And now we should have counterpart for momentum space. And also this hyperspace should have momentum space counterpart, and it is naturally 8-dimensional Minkowski space. It must be complexified because momenta turn out to be complex, also classically, because all these space-time surfaces contain Euclidean regions. So that one has this complexified M8, and it has interpretation as complexified octonions. And one can turn everything upside down and start from complexified octonions. And one ends up with M4 cross CP2 when one requires this duality. P-adic number fields are second part of this approach. P-adic physics would define physical correlates of cognition. P-adic space-time surfaces, for instance, and adelic physics as fusion of real and various p-adic physics to form a kind of book-like structure, 2-adic physics, 3-adic physics, 5-adic physics, and so on, would form this entire physics, including cognition and sensory experience. And here number-theoretical universally is central principle, and polynomials with integer coefficients are universal. They make sense in all number fields, and their solutions roots make sense in all number fields. This leads to the number-theoretical physics and makes it highly detailed. Physics as number theory vision involves both classical number fields, reals, complex numbers, quaternions, octonions, and p-adic number fields. Also finite fields are involved. Quantum tgd is analog of wave mechanics, as already noticed. Momentum position duality is essential for wave mechanics. It does not generalize to quantum field theories. It should be realized for particles as three-dimensional surfaces. And now the counterpart of momentum space would be 8-dimensional Minkowski space, tangent space, or cotangent space of M4 cross CP2. It, however, turns that one must complexify this momentum space. Already classically, momenta are complex since one has Euclidean space-time regions, Euclidean induced metric, and they give imaginary contribution to the total momentum. So that complexified octonions must be used. Also now basic geometric objects are four-dimensional surfaces in this eight-dimensional space. They would be partially determined by the roots of a polynomial p with integer coefficients. This guarantees number-theoretical universality. These equations make sense in all number fields, also p-adic number fields. And roots of these polynomials, they would correspond to complex mass square values, algebraic numbers. They define three-dimensional mass cells in three-dimensional hyperbolic spaces, in four-dimensional Minkowski space, in eight-dimensional Minkowski space. Everything complexified. Also, the holography must have a counterpart, number-theoretic counterpart. The holographic data for four-dimensional surface in M8, it would correspond to a set of three-dimensional surfaces at mass cells defined by these roots of this polynomial. They these three-dimensional surfaces should be continued to a four-dimensional surface. And now one must have also dynamics, number-theoretical dynamics. It would be fixed by associativity. The normal space of four-dimensional surface would be associative. A times BC is equal to AB times C. These normal spaces would be quaternionic. Okay, the analog of time evolution is now energy evolution or mass evolution. What is its interpretation? The natural interpretation would be as an analog of coupling constant evolution. When we change resolution, we change the mass scale determined by the root of polynomial, and the state changes because the resolution changes. The state looks different. This looks the most natural interpretation, and it would mean that one would have coupling constant evolution at this level, or its generalization. And then one has this momentum position duality. It generalizes to momentum, to M8H duality. The surfaces in M8 are mapped to M4 cross CP2. And this means that coupling constant evolution corresponds to time evolution. These two big evolutions are obtained from each other. This is quite non-trivial prediction. The choice of H, this hyperspace, is unique from the existence of this duality. CP2 has number-theoretic interpretation, and this makes this tgd unique. When one starts from M8 octonions, one ends up with M4 cross CP2 and this duality. TGD is unique also from the condition that twist or lift of TGD exists. M4 and CP2 are only four-dimensional spaces for which twistor space is Kähler's manifold. And also the condition that the geometrization of standard model fields, symmetries and quantum numbers is possible leads to the same outcome. And of course, the mathematical existence of world of classical worlds suggests that the theory is completely unique. And the proposal is that this is the unique solution. Physics as number theory involves also p-adic number fields. P-adic physics could be regarded as physics of cognition. All p-adic primes are involved, p equal to 2, 3, 5, and so on. And one must combine these p-adic physics with real physics to form a book-like structure. Real numbers, 2-adic, 3-adic, 5-adic fields, number fields, they would appear as pages of this big book. And one must also allow algebraic extensions of rationals, which in turn induce extensions of p-adic number fields. One obtains entire library of books. Every extension of this kind of book based on rationals belongs to this big library. And the interpretation of this p-adic number fields is indeed as physics of cognition. Real number fields correspond to sensory experience. One would have number-theoretic universality, this hierarchy of adeles, these books, determined by extensions of rationals, it would be determined by polynomials. and define an evolutionary hierarchy. Polynomials with integer coefficients. Their roots are defined in all number fields. They make sense in all number fields. A number-theoretic vision predicts a hierarchy of phases of ordinary matter. They would be labeled by effective Planck constant, multiple of some minimum values smaller than ordinary Planck constant. This integer n is identifiable as a dimension of extension of rationals, assigned with polynomial p, and is equal to the order of Galois group. And Galois group and its normal subgroups, they would act as symmetric groups, number-theoretical symmetric groups of number-theoretic physics. Galois confinement appears as a universal mechanism for the formation of bound states. The virtual fermion momenta have components which are algebraic integers in the extension, which is defined by polynomial p when the momentum unit is defined by the scale of causal diameter defined in the quantization volume in zero-energy ontology. The momentum components for physical many fermion states, they are integers. This will be the quantization condition. Quantization of momentum for particles in box is the analog. Also, mass squared is integer. This conforms with the string mass formula. And this means that one obtains conformal confinement as a special case. Conformal weights for fermions are in general complex and algebraic numbers, but the total conformal weight is integer. One of the most important predictions of physics as number theory is dark matter. Dark matter would have number-theoretic explanation. The phases of ordinary matter for which this effective Planck constant is larger than Planck constant, they behave like dark matter. Particles in the same vertex must have same value of effective Planck constant. This integer n, it serves as a measure for algebraic complexity, and in quantum biology also as intelligence quotient, one might say. And this makes possible quantum coherence in arbitrarily long length scales, which are typically proportional to effective Planck constant. For hydrogen atom, they are proportional to its square even. And these phases with effective Planck constant larger than ordinary Planck constant, they reside at magnetic bodies. This means that one has slaving hierarchy. Magnetic flux tubes contain flux tubes, inside them contain, and so on. And at the bottom is ordinary matter. One has slaving hierarchy of these phases with effective Planck constant. Nottale introduced long time ago what he called gravitational Planck constant. It would be particular case of effective Planck constant. It is given as product of gravitational Newton's constant and two masses, big mass and small mass, m and small m, and divided by velocity parameter, which must be it can be larger than 1. And the proposal is that this gravitational Planck constant plays a key role in quantum biology. And gravitational monopole flux tubes would carry dark matter characterized by this gravitational Planck constant. Further observation is that energies of quantum system increase with effective Planck constant. This holds quite generally. This implies instability against decrease of effective Planck constant. The dark state can decay to ordinary particles, and therefore metabolic energy feed is needed to increase the value of effective Planck constant, which tends to decrease spontaneously as dark matter transforms to ordinary matter. This would explain why metabolic energy is so important in biology. Second standard explanation would be based on self-organization, non-equilibrium thermodynamics. Next, I will consider some aspects of quantum gravitation and quantum biology in tgd framework. The motivation comes from this Nottale's proposal for gravitational Planck constant, which generalizes in tgd framework. I will start by listing some strange numerical coincidences, knowing quite well that this might be regarded as numerology. The gravitational Planck constant one can assign to this small mass m Compton length. This Compton length does not depend on this small mass. This reflects equivalence principle. It is essentially Schwarzschild radius divided by 2 and also by this velocity parameter, which is always below c. And in order to obtain large enough Compton length, gravitational Compton length, one must have large enough mass. For instance, for Sun and Earth, this condition is satisfied. For Sun, the gravitational Compton length, which defines lower bound for quantum coherence scale, this would be given by Earth radius in a good approximation. Strange coincidence indeed, and for Earth one has 0.45 centimeters, which happens to be the size scale on a snowflake. We know that snowflakes are somewhat mystical. They are kind of zooms of what exists in atomic length scales for ice crystals. Further coincidences. Consider solar gravitational Planck constant for Cooper pair of protons, and biorhythm, which is 1 year, very essential biorhythm. In this case, the corresponding energy, E equal to h grav times frequency, is equal to metabolic energy currency of 0.5 electron volts. One can consider also Earth. In this case, gravitational Planck constant for Earth and for proton. And now it is natural to consider biorhythm of 24 hours, 1 day. Now one obtains 0.05 electron volts. This is Coulomb energy assignable to cell membrane, the energy which charged particle obtains when it goes through the membrane. There is further numerical coincidence. One can consider self-interaction energy of water blob with Planck mass. It happens to have a size of neuron, 10 to minus 4 meters is the radius. This energy corresponds to an energy scale of 3.5 milli-electron volts. It is identifiable as the miniature membrane potential. My hope is that these numerical coincidences might give some trust that this approach might work. Universal quantum gravitational mechanism of metabolism. This I will consider next. When one lifts a particle with some mass to some height, its gravitational binding energy is decreased. And when it drops down, it gains kinetic energy, and this kinetic energy can be used. For instance, it could serve as metabolic energy, increasing the value of effective Planck constant. It could be stored as energy to biomolecules, proteins, and so on. Research says that if one lifts charged particles to gravitational flux tubes of length of Earth size, one can load gravitational metabolic energy batteries. When these charged particles drop down, they liberate energy, and this could be used as metabolic energy. This kind of mechanism might be even fundamental for entire metabolism. So then one can ask whether the transfer of protons, electrons, ions to dark particles at upwards directed gravitational flux tubes with size scale of Earth radius and possibly induced by solar radiation, for instance, whether it could load gravitational metabolic energy batteries. Dropping back would liberate metabolic energy. What comes to mind are dark hydrogen bonds and valence bonds. I have considered these as examples. Dark protons would be at dark hydrogen bonds very, very long, and dark electrons at very, very long valence bonds. The standard metabolic energy currency of 0.5 electron volts, it happens to correspond to the gravitational binding energy of proton in the Earth's gravitational field. Could dark proton triplets are needed, in fact, could they give 0.5 electron volts liberate this energy when they drop back and become ordinary protons. And I have also proposed that they could define dark genetic codons. This dark genetic code would be fundamental realization of genetic code. Also dark photons could realize genetic code and used in communications between dark matter and also dark matter and ordinary matter. There is also the question, what about electrons? We could use also electrons to replace proton mass with electron mass in gravitational Planck constant. In this case, one would obtain metabolic energy currency of 0.25 milli-electron volts. And Adamatsky has given empirical evidence that this kind of metabolic energy quantum exists. What quantum gravitation and quantum criticality? Living systems are critical. This guarantees maximal sensory sensitivity and optimal motor control. The quantum critical magnetic body, it could force the criticality of a living system. Ordinary matter is certainly not quantum critical, and since it is not macroscopic quantum coherent, it is magnetic body would be quantum coherent. One can ask whether magnetic bodies could appear at quantum critically in quantum superposition with varying values of this velocity parameter beta appearing in this gravitational Planck constant. Whether the selection of one value of beta could be seen as counterpart of orch-or, this is an interesting question. Microtubules are critical, certainly. Their length is changing all the time inside actions, and could magnetic bodies of microtubules control membrane potential by transferring protons and electrons to gravitational flux tubes, which would have a size of Earth scale. This would change the effective charge of magnetic microtubule, and in this way also the membrane potential. Could this mechanism be involved with nerve pulse transmission and with the transmission of potential of waves of membrane potential? Then comes what is essential for life? Could what magnetic body be a quantum critical system at the physiological temperature range? Could magnetic bodies of water blobs make them candidates for protocells? One can ask also whether quantum criticality at the level of magnetic body of water could induce large density fluctuations at the level of ordinary biomatter. This could be assignable to criticality for ordinary phase transitions, such as melting and boiling and arrow phase transitions in biosystem. Sol-Gel phase transition is an example which comes also in mind. Could quantum gravitational state function reduction induce this kind of density changing phase transitions to a scaled state in presence of energy field? One interesting question is whether snowflakes could be corpses of quantum life forms living at a criticality for freezing. Emoto's work suggests this. And then there is also the fourth phase of water studied by Planck. He found that a phase transition to a rather strange phase occurs in presence of Gel phase in water. Also radiation by, for instance, infrared radiation is needed. The stoichiometry of water changes H1.50 is obtained. Part of protons go somewhere, and they could go to the magnetic body in tgd universe. Sequences of dark protons would be formed, dark nuclei, and one could imagine that these dark proton triplets would form define codons or fundamental genetic codes much more fundamental than the ordinary chemical one, which would have appeared much later in evolution. This genetic code would be realized already at the level of water. The Coulomb energy assignable to cell membrane 0.05 electron volts, it is of the order of thermal energy at physiological temperatures. Could this energy be involved with this phase transition? This biorhythm of 24 hours a day, this biorhythm corresponds to energy of 0.05 electron volts for gravitational Planck constant of Earth proton pair. It is time to summarize. In the geometric view of tgd, one considers spacetime surfaces in M4 cos CP2, and in number-theoretic view, 4 surfaces in 8-dimensional Minkowski space. Actually, it's complexification. This framework predicts a hierarchy of phases of matter, characterized by effective Planck constant, with dark matter as phases of ordinary matter at magnetic electric bodies, and controlling ordinary matter. So tgd provides a quantum gravitational view of biology, suggesting new insights into metabolism and generation of coherence. Quantum coherence at magnetic body would create induced forced coherence at biological body. And the generation of gravitational binding energy by radiation, for instance, kicking these charged particles to gravitational flux tubes could liberate energy. It could be usable as metabolic energy, it would be stored to molecules, and so on. This would connect quantum gravitation and biochemistry. And the quantum criticality of water, or its magnetic body, would be central for biological systems. And in particular, microtubules and membrane potential could be controlled by gravitational magnetic bodies of water. Various numerical coincidences support this view. I mentioned some of these numerical coincidences, there are many more. There is a lot of material related to tgd. First of all, there are books and articles at my homepage, 26 books and a lot of articles. There is material in ResearchGate and articles published in journals founded by Hopping Who, beginning from year 2010. In particular, one should mention 2 articles related to this talk, how animals without a brain can behave as if they had a brain. Second article is comparison of orch-or hypothesis with a tgd point of view. And they can be found at my homepage also. And a summary of basic ideas of tgd and their fusion to mathematical theory is described in the third article listed here.